Alright, so I'm gonna be going over the chapter modules point 0.5 and point 0.6 in this video. So pretty pumped. I'm just gonna say it like that. I'm fucking excited. Anyways, alright. Introduction to the compiler grade libraries. Okay, sweet. Continue our discussion of this diagram from the previous lesson. Point 4, introduction to C++. Step 1, define the problem. Design the solution. Write a program that implements the solution. Compile the program. Link object files. Test the program. And debug it. Okay. Discuss steps 4 and 7. Compiling your source code. In order to compile C++ source code files, we use a C++ compiler. C++ compiler sequentially goes through each source code .cpp file in your program and does two important tasks. First, the compiler checks your C++ code to make sure it follows the rules of the C++ language. If it does not, the compiler will give you an error and a corresponding line number to help pinpoint what needs fixing. The compilation process will also be aborted until the error is fixed. By the way, okay, if you didn't know what this means by up here, when I'm talking about going sequentially through each code file, it'll sequentially means like goes one by one through each file. So it builds it up from top to bottom, or from bottom to top, whatever you want to say. And then yeah, so the header files, like your .h files, aren't actually built; they're included in your source code files. So I know, pretty gangster. Anyways, second, the compiler translates your C++ code into machine language instructions. These instructions are stored in an alternative or in an intermediate file called an object file. The object file also contains metadata that is required or useful in subsequent steps. Object files are typically named name.o or name.obj, where name is the same name as the .cpp file it was produced from. For example, if your program had 3 .cpp files, the compiler would generate 3 object files. So source file, calculator.cpp, generates calculator. Same thing for all these other things. C++ compilers are available for many different operating systems. We will discuss installing compilers shortly, so there is no need to do so now. Step 5, linking object files and libraries. After the compiler has successfully finished, another program called the linker kicks in. The linker's job is to combine all the object files and produce a desired output file, typically an executable file. This process is called linking. First, the linker reads into each of the object files generated by the compiler and makes sure they are valid. Second, the linker ensures all cross-file dependencies are resolved properly. For example, if you define something in one .cpp file and then use it in a different, wait, might have it. What the hell? I don't know what this called. The linker connects the two together. The linker is then able to connect a reference or to something with its definition. You'll get a linker error. Linking process will be aborted. Third, the linker also is capable of linking library files. A library file is a collection of precompiled code that has been packaged up for use in other programs. Like library files, at least the ones I've used, are like .lib files. So like d3dx11.lib, or like different things like different like for graphic utilities and shit like that. Which we'll talk about that later. But I'm sure there's tons of other library files, but those are the only ones that I've used or had to like explicitly input for my linker to use. C++ comes with an extensive library called the C++ standard library, usually called the standard library that provides a set of useful capabilities for use in your programs. One of the most commonly used parts of the C++ standard library is the input/output library, often called IOStream, which contains functionality for printing text in a monitor and getting keyboard input from a user. Almost every C++ program written utilizes the standard library in some form, so it's very common for the standard library to get linked into your programs. Most C++ linkers are configured to link in the standard library by default, so this generally isn't something you need to worry about. So yeah, so when it comes to us coding, we're not going to need to include the standard library because our linker will already do it for us. So, and it'll have other like .lib dependencies that we need that'll just automatically be enabled or installed. You can also optionally link other libraries. For example, if you were going to write a program that plays sounds, you probably would not want to write your own code or read in the sound files from disk. Check to ensure they were valid or figure out how to route the sound data to the operating system or hardware to play through the speaker. That'd be a lot of work. Instead, you'd probably download a library that already knew how to do those things and use that. We'll talk about how to link in libraries and create your own in the appendix. So yeah, this is basically just showing. So it takes all the .o files, it takes the standard library, other libraries, and it all goes into the linker, and the linker links it all together, and then it produces the executable file. So it compiles, makes these .o files, then the linker will take the libraries and all your compiled files, link them inside of each other, or link them together, right? As a fucking linker, like chain links, and then put inside the executable. So pretty gangster. Once the linker is finished linking all the object files and libraries, then assuming all goes well, you have an executable file that you can run. Because there are multiple steps involved, the term building is often used to refer to the full process of converting source code files into an executable that can be run. A specific executable produced as the result of building is sometimes called a build. For advanced readers, for complex projects, build automation tools such as Make or Build2 are often used to help automate the process of building programs running automated tests. While such tools are powerful and flexible, because they're not part of the C++ core language, nor do you need to use them to proceed. We will not discuss them as part of this tutorial series. Step 6 and 7, testing and debugging. This is the fun part. You're unable to run your executable and see what it does. Once you run your program, then you can test it. Testing is the process of assessing whether your software is working as expected. Basic testing typically involves trying different input combinations to ensure the software behaves correctly in different cases. The program does not behave as expected, then you will have to do some debugging, which is the process of finding and fixing programming errors. We will discuss how to test and debug your programs in more detail in future chapters. This is talking about IDEs. Note that steps 4. Yeah, IDEs are just editors, like text editors, that have in combination compilers, linker, and debuggers. Like, we're going to be using Visual Studio. So if we just pull up like my project I'm working on, when we actually see how the compiler does it in the so let's just build this. So build. Oh, there's already one up to date. Let me rebuild. So yeah, so you see it goes sequentially from the source code files. But the thing is there's only one source code file in this project. Let me turn on Solution Explorer. So yeah, I only have 2 header files and 1 source code file. So it's only going to build a source code file and it's going to link them all together. Anyways. Is debugging also available before compilation, or is it something to C++? I mean, I cannot debug a program that don't even compile. If I can, maybe it would be great. And you can't debug a program before it's compiled, nor can you debug a program. I think the answer. Well, yeah, this thing, so you can't debug a program without being able to compile it. But when you run it, and it'll break, it'll have errors. It'll generate errors for you. Like if I delete this code and I run this, it'll compile correctly. But if I come across this, if I just put, oh well, that's not, I'd have to wait till I get to there. Well, let me just, okay, let me go night, right, attack. So invalid input and it breaks. But well, that wasn't really a good example, was it? It doesn't really. But yeah, basically, it'll give you your errors right here, and they'll disappear when you rebuild. So let's go to the next one. Installing an integrated development environment. Okay, this is going to be going through installing Visual Studio. This is pretty easy. I guess I'll go through it, yeah. A typical modern IDE will include some way to easily load and save your code files, a code editor that has programming-friendly features such as line numbering, syntax highlighting, integrated help, name completion, automated source code, formatting, a basic build system that will allow you to compile and link your programs or program into an executable and then run it, an integrated debugger to make it easier to find and fix software defects, some way to install plugins so you can modify the IDE or add capabilities such as version control. Some C++ IDEs will install and configure a C++ compiler and linker for you. Others will allow you to plug in a compiler and linker of your choice installed separately. And while you could do all of these things separately, it's much easier to just install an IDE and be able to do all these things from a single interface. So let's install one. Choosing IDE. The obvious next question is which one? Many IDEs are free in price, and you can install multiple IDEs if you wish to try more than one. Recommend a few of my favorites. If you have some other IDE in mind, that's fine too. Concepts we show you in this tutorial should generally work for any decent modern IDE. However, various integrated development environments use different names, layouts, key mappings, etc. So you may have to do a bit of searching in your IDE, find the equivalent function. To get the most value out of this site, we recommend installing an IDE that comes with a compiler that supports at least C++ 17. If you're restricted to using a compiler that only supports C++ 14 due to educational or business constraints, many of the lessons examples will still work. However, if you encounter a lesson that uses capabilities from C++ 17 or newer, and you're using older language compiler, you'll have to skip it or translate it to your version, which may or not be easy. You should not be using any compiler that does not support at least C++11, which is typically considered the modern minimum spec for C++. Recommend installing the newest version of a compiler if you can't use the newest version. These are the absolute minimum compiler versions with C++17 support. So GCC 7, Clang++, 8, Visual Studio 2017, which I think we're using 2022, so Visual Studio for Windows. If you're developing on Windows 10 or 11, then we strongly recommend downloading Visual Studio 2022 Community. Once you run the installer, you eventually come to a screen that asks you what workload you would like to install. Choose desktop development with C++. If you don't do this, then C++ capabilities will not be available. Default options selected on the right side of the screen should be fine, but please ensure that the Windows 11 SDK or Windows 10 SDK, that if that is the only one available, is selected. Windows 11 SDK apps can run on Windows 10. Oh yes, just make sure you choose desktop development C, and then make sure you have all the stuff selected that I have selected, and press install. This space and our download size are a challenge. Microsoft still offers Visual Studio Express 2017 for Windows. Code blocks. Yeah, we're not gonna worry about installing code blocks. Code blocks is yeah, it's just okay. Just install this Windows version. If you want to know how to install the Linux version, you literally just take this command and copy paste it. Okay, and it'll instantly install. And it'll ask you once you load it up when you launch code blocks the first time. Yeah, I mean, like I said, I wouldn't use code blocks, but if you want to. Visual Studio for experienced Mac OS or Windows users. Yeah, we're not going to use Visual Studio Code. Visual Studio Code is not a good option for C++ beginners, and readers have reported many different challenges getting Visual Studio Code installed and configured correctly for C++. Please do not choose this option unless you're already familiar with Visual Studio Code and prior to use, or have experienced debugging configuration issues. We cannot provide installation or configuration support. So yeah, let's just do what is the standard, right? So just use Visual Studio. Other Mac OS IDEs. Other popular Mac OS choices: Xcode. Xcode's a pretty good one for Mac. It's available to you, and the Eclipse code editor. Eclipse is not set up to use C++ by default, and you need to install the optional C++ components. Basically, if you download Eclipse, it just you go to like your options or your extensions, and you can just manage your extensions and add C++. Okay. Can use a web-based compiler, yes, for your things while your IDE is downloading, or if you're not sure you want to commit to installing one, you can choose a tutorial using a web-based compiler. Recommending one of the following tutorials: Point, Wandbox, Goodbolt. Godbolt can see assembler. Huh. Wow, I can see assembly. That's crazy. All right. Can I use a command line compiler, for example, G++ and Linux? Yes, you can. Yes, we don't recommend it for beginners. You need to find your own editor and look up how to use it elsewhere. Oh, for anybody, if you want to learn C, I would say after you finish reading through everything on this website, if you're going to, if you really want to commit to learning C++ and C, I would recommend you watch Handmade Hero. Yeah, I'd say you should watch this guy's full series, to be honest. I haven't watched it fully. I've watched a couple episodes, and I've watched his intro to C on Windows, obviously, because I wanted to learn. But he makes an entire game from scratch and streams the entire thing using only the Windows API and C. I don't think he uses C++, but if you know C, it's the working blocks of fucking C++, or the building blocks C++, as we saw before. C++ is a superset that adds object-oriented programming, like classes and shit like that. Anyways, can I use a command line compiler? Yes. Can I use other coders and IDEs such as? Yeah, you can, but I wouldn't recommend that. IDEs to avoid. You should avoid the following IDEs altogether because they don't support at least C++. Borland is for Mac that supports C++. Dev C++ not actively supported. There is no good reason to use an outdated or unsupported compiler when lightweight for alternatives that support modern C++ exist. When things go wrong, aka when IDE stands for I don't even. IDE installations seem to cause their fair share of problems. Installations might fail outright, or installation might work, but the IDE will have problems when you try to use it due to a configuration issue. If you encounter such issues, try installing the IDE, assuming it is installed in the first place. Reboot your machine, disable antivirus, or malware temporarily. Try the installation again. Okay, this doesn't really matter. Moving on. Once Ready is installed, we can get on to the first step. Alright, well, I'm gonna stop right here and snip it from the next video. So probably about like a couple hours. But if you want me to make a video on installing and setting up Visual Studio, just leave a comment in the comment section, whatever the fuck, and I guess I can do that if you need the help. But there's plenty of YouTube videos out there going over installing it. So, and if you're watching this, I'm assuming you. I don't know. I mean, would you be considered stupid if you're watching me read this out because you're not reading it yourself? Honestly, I have no idea. I would say you should probably read it yourself because you're your best teacher. I would say. I don't think anybody else can teach you better than yourself can. So if you want to read through this on your own, I'd recommend it. But I'm mainly just making these videos just so I can reinforce the information in my head by recording it and sticking to a timeline and uploading videos. And yeah. Anyways, I'm done. Yeah, no, I'm done.